Hello everyone, I'm Akash Reddy from Sri Venkateshwara Engineering College. So today's topic is Find S algorithm. The topics which are going to be covered are what is Find S algorithm, how it works, advantages, limitations, applications, and implementation of Find S algorithm. At first we have is what is Find S algorithm. The Find S algorithm is a simple and effective machine learning algorithm that is used to construct the most specific hypothesis from a set of training examples. It is being widely used in various fields, including data mining, pattern recognition, and AI. In order to understand Finder's algorithm, we need to have a basic idea in the following concepts given below. They are concept learning, general hypothesis, and the specific hypothesis. At first we have is concept learning. The most of the human learning is based on past instances or experiences. For the example, we are able to identify any type of vehicles based on certain features like make, model, etc. These specific features differentiate the set of cars, trucks, etc. for large set of vehicles. These features that define the set of car, trucks, etc. are known as concepts. Similar to this, machine can also learn the concepts to identify whether an object belongs to a specific category or not. Any algorithm that supports concept learning requires the following data. They are training data, target concepts, and actual data objects. Next we have is general hypothesis, which is represented in question mark. General hypothesis is an explanation for something. The general hypothesis is basically states the general relationship between major variables. In the example we can see ordering of an food. I want a burger. Next we have a specific hypothesis, which is represented in empty set symbol. The specific hypothesis fills in all the important details about the variables given in the general hypothesis. In the example, we are able to see, I want a cheeseburger with the chicken with a lot of sauce, etc. And it is represented in empty set symbol. This is a flowchart of a Finder's algorithm. In the example, we can understand the concept easily. Let's consider a simple example of a two attributes, color and size. Suppose we have the following positive training examples, and the values are red, small, red, large, blue, and small. To learn the concepts of color and size, we will use Find S algorithm as follows in the below. The first step, initializing the hypothesis S to a set of all possible attributes and values. S equals to color question mark, size question mark. Question mark represent general hypothesis. Processes. In the second step, processes positive example. For the first positive example, we will consider the values red and small. For the second positive example, we will consider red and large values, and S is updated as follows. S equals to color red and size as question mark. For the third example, we consider blue and small values, and the S is subsetted as follows: S equals to color question mark and size small. The third example, we consider blue and small values, and S is subsetted as follows: color question mark and size is small. At the third step, output step, the final hypothesis is more specific hypothesis that is consistent with a positive example, color red and size small, value and attributes. This hypothesis suggests that people prefer objects that are red and small. The next we have topic is advantages. Simplicity. The algorithm is simple and easy to understand, making it good starting point for learning about machine learning and classification. Efficiency. The algorithm is computationally effective and can quickly learn from a large data set. Accuracy. The algorithm produces a hypothesis that is guaranteed to be consistent with all positive training examples, making it highly accurate for a classification task. And incremental learning. The algorithm can easily extend to support incremental learning, which means it can learn new concepts from a new data set without forgetting previous learning concepts. And the limitations of finder's algorithm are: 1. There is no way to determine if the hypothesis consists throughout the data. Inconsistent training set can actually mislead the finder's algorithm since it ignores the negative examples. The finder's algorithm doesn't provide a backtracking technique to determine the best possible changes that can be done to improve a resulting hypothesis. These are the limitations of finder's algorithm. And in the applications we have text classification, image recognition, natural language processing, medical diagnosis, and fraud detection. At first we have text classification. The algorithm can be used to learn text classification models that can automatically categorize text document based on their content. Next, image recognition. The algorithm can be used to learn models from the image recognition tasks such as recognizing an object in image. Natural language processing. The algorithm can be used to learn models from natural languages processing tasks such as sentiment analysis and part of speech tagging. Medical diagnosis. Algorithm can be used to learn models from medical diagnosis such as predicting the presence of a disease based on the symptoms and other patient information. Fraud detection. Algorithm can be used to learn models for fraud detection in financial transactions such as credit card fraud detection. At last we have implementation of a find S algorithm. The concept of this particular problem can be on what days does a person likes to go on a walk. Depending on time, weather, temperature, company, humidity, wind, and goes. Looking at the data set, we have 6 attributes and final attributes. that defines a positive or a negative example. In that case, yes is a positive, which means person will go for a walk, and negative means person doesn't go for a walk. So now we have a general hypothesis. But first, the attributes: morning, sunny, warm, yes, mild, strong. This is our general hypothesis, and now we will consider each example one by one, but only the positive examples will be considered. H1 and H2 will be replacing all different values in general hypothesis to get the resultant hypothesis. And this is the code for the finders algorithm in Python. And thus we get the following output.